Welcome to the Consul product updates. To kick us off, I wanted to spend a little bit of time talking about what brought us to the idea of Consul and the approach that it takes, given that it's a relatively unique product. And I think what it goes all the way back to is really the Tao of HashiCorp, which is a document we published around some of the essential kind of design philosophies we have for the whole portfolio, right? This includes things like our natural workflow over technology orientation, right? And what we mean by that is really focusing on what's the core workflow problem, but making sure that the tool is pluggable to different technologies, right? In Consul's case, for example, we don't really care if you're running on-premise or if you're running in cloud, if you're running on bare metal, virtual machine, containerized environment, etc. The actual environment, the platform, the technologies, Mac, Windows, Linux, etc., is designed to be pluggable against sort of a common workflow, right? And that's an approach we take in sort of all of our products. A different really important Tao for us is this idea of immutability, right? And when we talk about immutable infrastructure, it's really this notion that once I create a particular version, right? I have my version 1 server, for example, that I don't modify it in production anymore, right? I boot it from sort of this golden image that describes version 1, and then that's it, right? And if I wanted to deploy a version 2, I'd create a new golden image that describes version 2. I'd boot a server in that sort of image, and I never touch it again, right? So in this sense, it's immutable. We don't mutate it once it's been created. So this was always kind of a core ethos of HashiCorp from the very beginning. And I think if you go back to sort of circa 2013, right, to kind of put yourself into the realm of the tooling that existed, really a world that was heavy on things like configuration management, right? So the most common practice was you deploy a server, let's say a web server, and you want that web service to know the IP address of your API service or your database so that it can connect to it upstream. Probably the most common practice at the time was really you'd run Chef or Puppet or Ansible to update basically the IP address of that upstream service, right? So great, I deploy my web service, then I run Ansible, and say, great, the IP address of my database is 10.0.0.5, as an example. And so I think very early we sort of asked ourselves, okay, what would it take for us to get to sort of an extreme immutable view, right? To get to a point where I can deploy an image and with nothing else, no additional configuration management, no additional kind of convergence run, I could have that discover and connect to its upstream services, API services, databases, etc., without needing to run any additional configuration management, right? That was sort of the original problem, was really how do you think about kind of microservices in an immutable architecture, right? Considering that these things are dynamic. And what I mean by that is one option would be to bake the IP address into the machine image, right? So I can hard code the IP address of the database, let's say, in my web server's image, so when it boots, that IP is hard coded. But we didn't want to do that because then it defeats sort of being able to have a dynamic ephemeral infrastructure, right? If my database fails and it comes up at a different IP, or if I'm auto-scaling a service and IPs are coming and going, that would be a very brittle approach. So we didn't want to do something that was like a hard code. And so we really looked at this problem and said our first approach to this was, what if we could do something using a pure peer-to-peer gossip-based mechanism? So the first approach to this problem was building a tool that really used completely decentralized. You ran an agent on every node, and we would kind of gossip, in the true sense of sort of a gossip protocol, the IP addresses of the different services to one another, and they could use that dynamic catalog to basically figure out what are the upstream and downstream IPs, right? That was our first approach, and I think what we quickly found was it was a bit too unstructured, right? It didn't have a strong domain model of you have nodes and data centers and services, and there's health checks associated with it. So there wasn't this kind of domain model of how do these different pieces interact to one another. It kind of put the burden of that on the end user to define all of it. And by virtue of it being purely decentralized, it was hard to have a coherent view of the data center, right? At different points in time, each node would find out about a service coming and going. This is sort of fundamental part of the decentral nature of the gossip protocol. Versus if we could run a centralized server, we'd have a stronger consistency and a coherent view of what the data center looked like at any given time. So ultimately, that led us into the development of Consul. This was now in early 2014 that it was introduced, late 2013 that we started working on it, so almost 7 years ago. And the real focus was on this original service discovery use case. I want to launch a set of immutable images, right? They're going to have a Consul agent baked on it. can that console agent then dynamically register that node and say, great, this instance is now a web server running at IP1. The web server can then discover what's the IP of the API, of the database, of the cache, and this would be totally dynamic. So as nodes would come and go, right, or things would fail or they'd auto scale, the system would be able to handle it in a fully dynamic, elastic way, right? So that was the real focus, was really thinking about this kind of service discovery, this kind of networking automation. How does it work with a microservice and an immutable architecture? That's what we kind of strove to create in the initial version. And I think since then, we've kind of looked at Consul as being able to solve a broader set of networking automation challenges, but really that was the original inception behind the product.
Yeah, so that outlines the initial vision of Consul really well. We really wanted to solve this practical problem of an immutable image coming up and being able to join, a cluster immediately to find its database, to talk to any other dependencies it has, to get its configuration and things like that. And so when we looked at this problem, we described it broadly as a service discovery or service networking challenge. One of the things we put into the 0.1 release was a key value store. And I think that really threw people off to what we were trying to solve. I like to look back and feel it was a little bit unfortunate for us to put that key value store in there at that time, because we were in an environment where another tool called etcd came out a few months prior, 6 months prior, something like that, which was a distributed key value store that could be used to solve things like service discovery potentially. And when we put a key value store in Consul, it drew a lot of early sort of criticism in a sense, or just confusion around how Consul relates to etcd, when in reality, we never really thought we were actually in the same space. And so I sort of regret putting that key value store in there, because really what we were trying to solve was this problem that Armon brought up, which was bring up a node, make it available via DNS or the HTTP API or something like that. And that's where you could start to see the differences. We had built-in 0.1 DNS interface to find those services. Really quickly following up, we had ways to bring configuration via something like the KV into your service. And then fast forward to today, and we support many, many more use cases really focused at solving this broad service networking problem. We didn't want to build this toolkit where you could build those types of tools on top of Consul. We wanted Consul to be the solution, the final solution that made your service-oriented or microservice architecture really tick and work together. And so that's why Consul today has so many of these features out of the box. And to talk about all these features in detail, I'd like to introduce Nina Pemaraju, the Director of Product Management for Consul.